5 scientists whose work you rely on every single day and whose names almost nobody remembers. Let's start. Number 1. Roughly half the nitrogen atoms in your body, in your muscles, your skin, your DNA, got there because of this man. Around 1900, the world was facing a slow catastrophe. Crops need nitrogen, and as the population climbed, the supplies of usable nitrogen looked increasingly inadequate for the food demand ahead. The maddening part: nitrogen is everywhere. Nearly 80% of the air is nitrogen gas. But it's locked in a molecule so tough that most plants can't use it directly. Fritz Haber found the laboratory conditions that could force nitrogen and hydrogen to combine into ammonia, the raw material of fertilizer. That was only half the battle. Carl Bosch and his team then solved the immense engineering problem of doing it safely and continuously at the scale of a factory. The result is staggering. Synthetic fertilizer made this way now supports close to half of humanity. No discovery in this video has kept more people alive. And yet, Haber became one of the chief architects of chemical warfare, directing Germany's first large-scale chlorine gas attack at Ypres in 1915. About a week later, his wife, Clara Immerwahr, a gifted chemist herself, died by suicide. Why she did so is genuinely unknown, and the timing shouldn't be read as proof of her reasons. Born into a Jewish family, Haber was driven out of Germany by the Nazis in 1933 and died in exile a year later. In a final bitter twist, fumigant research connected to his institute led toward the chemical family the Nazis would later misuse in the Holocaust. But Zyklon B itself was developed by other chemists in the 1920s, and Haber neither devised it for genocide nor lived to see it. Members of his own extended family were later among its victims. His life is the sharpest warning here that scientific brilliance and moral wisdom are not the same thing. Number 2. Look at the Atlantic, and you'll notice something strange. The continental margins of Africa and South America fit together like pieces of the same puzzle. The same fossils, the same bands of rock appear on both sides of an entire ocean. A child notices this. The question is whether you dare to say out loud what it might mean. In 1912, a German meteorologist, not even a geologist, said it plainly: the continents move. They were once joined, and they've drifted apart. The geology establishment didn't just disagree, many ridiculed him. To be fair to them, he couldn't explain how continents could plow through solid rock, and several decisive pieces of evidence simply didn't exist yet. Wegener died on the Greenland ice in 1930 on an expedition still dismissed. Decades later, part of the answer came from a cartographer named Marie Tharp. Barred from the research ships because she was a woman, she mapped the ocean floor from the data instead, and found a vast rift valley running down the middle of the Atlantic, exactly where the seafloor seemed to be splitting apart. When she pointed it out, a colleague waved it away as girl talk. Her map became one of the key pieces of evidence that turned the tide. By the 1960s, ocean floor mapping, magnetic reversals, earthquake patterns and seafloor spreading had assembled the whole framework of plate tectonics, the single idea that explains earthquakes, volcanoes, mountains, and ocean basins. Here's the honest part. Wegener was right that the continents move, but wrong about the forces driving them. He reached the central conclusion before the evidence was strong enough to carry it, and died before it was accepted. Number 3. For most of life's history, Earth had only simple cells. Little bags of chemistry, like bacteria. Then, somehow, complex cells appeared. The kind with a nucleus and tiny power plants inside. The kind that build everything from mushrooms to whales to you. That jump is one of the biggest in the entire story of life. So how did it happen? In 1967, a young biologist named Lynn Margulis proposed an answer that sounded absurd. Those tiny power plants in your cells, the mitochondria, were once free-living bacteria. Long ago, one cell swallowed another, and, instead of digesting it, kept it. 2 organisms became one. She later said the paper was turned down by about 15 journals before anyone would print it. Some of the clues were already there, and later, molecular evidence made the case overwhelming. Mitochondria carry their own DNA. They have double membranes. They divide by a process much like the bacteria they descend from. Versions of the idea had been floated decades earlier and forgotten. Margulis's achievement was reviving it, marshalling the evidence, and refusing to let it go. Not every part of her wider theory held up, but on the origins of mitochondria and chloroplasts, she was right. Your cells are evolutionary mosaics, built from an ancient partnership between organisms that once lived separate lives. Number 4. By the early 20th century, astronomers could measure the distance to nearby stars using parallax, the tiny shift in a star's position as Earth moves around the Sun. But beyond that, the ruler ran out. A star might look dim because it's faint, or because it's unimaginably far away, and from here the two look identical. To measure galaxies, and eventually the universe, astronomers needed a new rung on the ladder. That rung came from Henrietta Leavitt, one of the women hired at Harvard to measure stars on photographic plates, eventually paid 30 cents an hour and gradually losing her hearing through her life. Studying a particular kind of pulsing star called a Cepheid, she found a clean rule: the longer a star's period, the brighter it truly is. Once other astronomers calibrated that relationship, measuring a Cepheid's pulse revealed its true brightness. Compare that with how bright it looks from Earth, and you can work out its distance. She had drawn the crucial markings on a cosmic measuring tape. About a decade later, Edwin Hubble used the calibrated Cepheid relationship to show that Andromeda lay far beyond the Milky Way, a whole other galaxy. Cepheid distances then became a crucial rung in the evidence that the universe is expanding, and the modern cosmic distance ladder still rests partly on her discovery. In 1925, the Swedish mathematician Gustav Mittag-Leffler wrote that he was seriously inclined to nominate her for the Nobel Prize, only to learn that she had died 4 years earlier and was therefore ineligible. Number 5. The Invisible One. A stream of data travels from the edge of the solar system through billions of kilometers of noise and is reconstructed with extraordinary accuracy on Earth. A film crosses the planet and arrives intact. For most of history, every copy of a message was a little worse than the last. Then one man worked out the rules that make this possible. In 1948, Claude Shannon published a paper that turned information into something measurable. He made the bit, a word suggested by his colleague John Tukey, the basic unit of information. And he proved something remarkable. Every communication channel has a maximum reliable rate, and below that limit, clever coding can make the chance of error vanishingly small. A decade earlier, as a student, he'd shown that simple electrical switches could carry out logic itself, the idea underneath every digital circuit. He was also the sort of mind who built a machine whose only purpose was to switch itself off. Every text you've sent, every film you've streamed, every photo from a distant spacecraft relies on the rules Shannon wrote down. He didn't build the internet, he did something deeper. He defined what was possible. And here's a small modern footnote. One of today's best-known AI assistants, Anthropic's Claude, is named in his honor, so perhaps, of all 5, he's not quite so forgotten after all. So there they are. Haber, who pulled food from the air. Wegener and Tharp, who showed us the ground is moving. Margulis, who found the partnership inside our cells. Leavitt, who gave us the size of the universe. And Shannon, who taught the world to measure information. Hopefully, the next time you think of their discoveries, you'll think of them too.